Here we go. Okay, good afternoon. So sometimes I will look into your camera, sometimes I will look into the camera that's recording, so they are a little offset from each other. So you may not see eye contact at all time. Anyway, the purpose of this is to give you some guidelines for presenting professional papers. By professional, I mean in a conference environment or in a job interview environment or in a serious research review or research progress review, that sort of thing. For internal reviews, we don't have to do any of this or most of this, but this is just to prepare you for the future, because at some point you will have to do all of these. So we have a certain infrastructure for all of these things that we want to do, including LaTeX for creating papers, iDraw for drawing figures, and MATLAB for drawing, processing data, and then drawing nice plots. So these are all in place, and you just have to know which one to use when, what type of format, what type of template you should use, etc. So what we'll do today, I just want to point out some common mistakes that people make. And Atharoff and Yikun should not take this personally, because this is something that every student does. And I finally realized that instead of repeating this to every student, I have graduated 20-some PhDs so far, and every time I have to repeat all of this, right? I figured I will talk to you guys at the same time, and I will also record it. So in the future, any student comes in will just watch this video just the way you guys watch the iDraw video and learn how it works, okay? And if you have any questions anytime, don't hesitate, you can ask questions. All right, so a few basic points. Every font in your presentation has to be bold, okay? Now here, everything is bold, so that's great, but I just write it here and you add that to your own notes so that in the future you know. Every font should be bold. The font type should be Arial, also known as Helvetica. And this is because it turns out that this font is the easiest on the eye. So people who see this font size, this font, can see it much better. If you see someone using Times as a font in presentations, it means that he has never taken a public speaking class. He doesn't know that Times is terrible for presentations. Okay? All right. Then here, the way this works is that you put your name, and then you say and then you put advisor's name, right? And then you say electrical engineering department, and then University of California, Los Angeles. Okay, so that's how you show your affiliation. If you want to put a date, that's great. It also shows a timestamp for when this presentation was created. Now, we use this sort of logo in our presentations. Sometimes in conferences we cannot do that, but for other presentations we do. Sometimes this becomes problematic in terms of constraining the space that you have, the vertical space that you have. So if that's an issue, you can keep it only for the title slide and just remove it for all other slides. Okay? You don't have to keep it for all other slides. It's just the title slide, that's fine. So that's another thing. And finally, I have seen this over and over again, especially among you guys, that for some reason you don't use a master slide in PowerPoint. You sort of copy, for example, when it comes to here, I've seen different types of modus operandi. So some of you, for example, have copied this title, this text, from another slide or something. So when I go to the master slide and I say, okay, I want this to not be black, but I want it to be blue, then it's difficult because it doesn't propagate to all of the slides. So you should always use one single master slide for all of the slides that you produce. The title has a separate master, right? Because this title is different. It doesn't have a line, right? You should use one master for that, and then you should use one master for these, and only one master. There's no reason to change it. The way I like to use the master is, the way I changed it recently, and I sent it to Atharoff and Yikun as an example, is that actually I changed this to blue And I changed to a different font because that font is a little nicer, only for the title, for this title of the slide. That font is called Tahoma. Okay? And then I changed this entire bar to red. So the combination of red and blue makes it look nice, and that's what you should be doing. All right? Okay. So for plots, this plot was taken from ISC, and that's fine for this internal presentation. But if you were to present this in a big conference, the difficulty is that this font is too small, right? So they project it on the screen, but people who are sitting in the back of the room cannot read this font. So they don't know which year this is, whether this is year, what it is. You inherited this plot from this reference, but if you really want to show this in a conference, you would have difficulty. You may have to recreate this plot yourself with bigger fonts. If these fonts are editable, you can edit them. Maybe in PDF you can go edit them or something, or you have to recreate it, whatever it is. But this brings up actually a much more important point. In every slide that I have seen it from every student, okay, I'm not exaggerating, the fonts turn out to be too small, okay, for conference presentations. The way to think about it is this. This font is, for example, 32, 36. This font is about 14. How could that be? Why should this font be so much bigger than this font? It doesn't make sense, right? Sure, this font should be bigger because it shows the general title, the general concept of the slide, but not so much bigger. So general rule of thumb that we have is that this font should rarely be less than 18 or 20. Okay, so that's the way to think about it. Otherwise, it's not legible. And when the fonts are so different, when you have a little font here and a big font here, a small font there, it just looks terrible. It's obvious that you're an amateur, you haven't done good presentations before. So that's something to pay attention to all the time for formal presentations. Okay, so moving on. All right, so you see that this slide is a little better. These fonts are a little better, but the problem is what? These fonts are not bold, right? These fonts should be bold, because bold makes the font look bigger, even though it's not bigger. It makes it thicker, so it's easier on the eye to read. All right. Okay, one other point is that every slide in your presentation must have a title. You cannot have a slide that says nothing here. That's a terrible presentation. Also, you can't just say, for example, prior art 1, prior art 2, prior art 3, prior art 4. Or architecture 1, architecture 2, architecture 3, meaning one slide is architecture 1, next slide is architecture 2, next slide. Each one of them has to have something specific to say. You can't just say 1, 2, 3, 4 forever, right? It means that you were too lazy to think of a nice comprehensive expression for this slide, so you just decided to just call it architecture 1, architecture 2. So you should pay attention to that too. Okay, so again, this plot has the same problems as before. This font is way too small, it's not legible, right? It's not bold. So all the stuff that we said before apply here as well. Generally for the titles that we use here, for the axes, we use uppercase for the first letter, like this, right? Data, rate, these are uppercase, not lowercase. And then the unit is in parentheses or in square brackets. It doesn't matter. I usually put it in parentheses, but some people put them in square brackets. So the units also should be shown. It is extremely important, as you learned in, I don't know, college, high school. It is extremely important to always label your axes, right? You should never ever show a plot. It doesn't matter whether it's an informal presentation or formal presentation. You should never ever show a plot whose axes are not labeled and not shown, right? Because it makes no sense. People will have a hard time understanding what it is. Okay. Any questions so far? All right, carrying on. Okay, so this is a MATLAB. This is the plot that was generated by MATLAB. I think Yikun just got it from this paper here. And it has a bunch of problems. Number one, again, the font is not bold. Number 2, this is what? This is supposed to be T subscript bit, right? So this is supposed to be something like this. But instead, it says T bit. What's the problem with T bit? It can be read as terabit, right? And of course, that's not the intention here. So that's why you should always pay attention to these things. If it's a subscript, it has to be a subscript. It doesn't matter which presentation you're showing it. Okay, let's see again. The fonts here are not bold. They should be bold. Okay, so all fonts here should be bold. Most of the points that we want to make about a slide should be bulletized, right? You should have a bullet and then a simple description, a quick description. Pay attention to the spacing between the bullet and the first letter. The spacing right now is too much. There should be less spacing, and you can adjust that. So less spacing. All right. Okay. Moving on to this and this. Okay. So again, everything should be bold. Here, see that the titles up here are bold, but the number is not bold. Everything should be bold. Whenever you have a number and a unit, you need a space between the number and the unit. Because this is not one word. These are two words. 600 millivolts, right? So you always need a space. In proofreading, we have a symbol wherever there's a space needed. And that is this symbol. Okay? So whenever I draw this symbol on a paper that you have written and I give it back to you, it means you need a space between this number and that, between these two, whatever they are. Okay, so you always need a space between the number and the unit. All of these need spaces. All of these need the spaces. Okay? So while we're on the subject, when do we have a hyphen between 40 nanometers and when do we have a space? Do you guys know? Okay, so if you say we are using, if you say the length of this transistor is 40 nanometers, then it's 40 space nm. But if we say we are using a 40 nanometer device, then there's a hyphen. Why? So here, 40 nanometer device. Because in this case, 40 nanometer is an adjective for device. And in English, an adjective cannot be more than one word. So if you have two words, you have to hyphenate them so as to make them one word. So that's an adjective for this device. Therefore, this adjective needs to be hyphenated. Okay? So if you say 40 nanometer technology, 40 nanometer transistor, whatever, 5 volt supply. So if you say 5 volt supply, it has to be 5 volt uppercase supply. Right? Because again, these are two words, 5 and volts. But when we convert them to adjective, first of all, adjective cannot be one word, more than one word, so it has to be hyphenated. And second, an adjective cannot be plural. So you cannot say 5 volts supply. It becomes a 5 volt supply. You drop the S when you read it, because an adjective cannot be plural. Okay? All right. What else can we say about the slide? Okay, any questions so far? All right. Okay, so this drawing was drawn by a student of my student. So Jerry Lee, this guy is Jerry Lee's student. Jerry Lee is a professor at National Taiwan University, was my student. That's why you see all of these look familiar, right? All these transistors, because they're doing it in iDraw. Jerry Lee went to Taiwan and forced his students to use iDraw just the way I force you guys to use iDraw, because it's a very nice program. So from when he went, first he said, okay, draw anything you want. And he was so fed up with the whole situation that he said, okay, everyone has to use iDraw. And for the past 15 years, all students have been using iDraw. So these look familiar, they look nice. Exactly what I have been telling you today, I told Jerry 15 years ago. Okay, so he inherited all of these and took them with him. So you see that the diagrams are very clear, very nicely drawn, very compact. So let's talk about compactness. When you draw a diagram, whether it's a block diagram or a circuit diagram, it is like drawing layout. So everything has to be compacted. The spacing between the objects in the drawing has to be minimized just the way you minimize the spacing in the layout, because eventually you're going to need the rest of the space for other stuff. So if you look, you see that the spacing between this line and this line, between this line and this box, between this arrow and this bubble, between this line and this line, everything is minimized because that's what we need. Why? Because if you draw these sparsely, meaning your spacing between is too large, and you bring it into PowerPoint, you cannot enlarge it anymore, right? Then it will look too small. The fonts will look too small. The diagram will look too small. So everything has to be drawn very compactly in iDraw, of course, legibly too, so that when you bring it into PowerPoint, you can enlarge it. So this is a good example of that. You can see that, you see the spacing between this box and this triangle, right? It's minimized. Everything is minimized so that we can enlarge it in PowerPoint. Now, here, the font size is reasonable, right? The font size is a little too small, but it's not that bad. This diagram looks very crowded. So if you were to present this diagram in a formal setting, what you would do is you would animate it. So you start out with, let's say, this serializer and this MSB path only. And say, okay, so our data comes to the serializer, then it goes through these latches and gets multiplexed up to this point. But that's for the MSB path. We also have an LSB path, and then animation comes in and shows this box and says, well, it's actually the same thing. We just draw it down here. And then you say, well, now I need to combine the LSB output and the MSB output. So with animation, this combiner and this combiner come to picture. And then you say, oh, actually, this also needs a clock. So the clock has to come from PLL. So this also comes in with animation. And then eventually you say, oh, I wanted to show you the internal circuitry of this combiner. And it's a bunch of differential pairs, da, da, da. So this also comes in with animation. Okay? So animation is a powerful tool that we have. Probably the best thing Microsoft ever gave us. Okay? Everything else is trash, but animation is really good. We can utilize that to our advantage because we can deliver a feed, a very complicated slide to the audience bit by bit so that they follow your thought process, they follow the evolution of the circuit bit by bit, and then at the end, everything on the slide makes sense. As opposed to suddenly dropping this on the screen, and now they don't know where to look, how to understand the diagram, right? So use animation to your advantage. Okay. Any questions? All right. So here's an example of a really bad drawing. This is from this paper. This is from IBM. I think it's from IBM, right? Anyway, this is a bad drawing. Why? Okay. So first of all, you see that the dot is almost invisible. Why? Because they made their line so thick and the dot so small that the dot doesn't show very well. So in more complex circuits like here, is there a dot here? Is there not a dot here? We don't know, right? It's hard to tell. Remember that when you show this to the audience has only like 2 minutes to absorb everything on the slide. So you should make your utmost to make sure that these little details are so clear that they don't create any barrier to their understanding, right? They just become natural. People see them, boom, they're done, right? They pay attention to the actual content of your talk, your slides, rather than be worried and be bothered with the details of, oh, I don't know, is there a dot here? Is another dot here? Is this connected to that or not, right? So you want these to be very clear. Okay. Also, never ever call anything out P, out N. It makes absolutely no sense, right? Is the voltage or the current? There's a voltage, V out. V out P or V out 1, V out plus. So oftentimes we write it like this. V out plus and V out minus. Or you can write it as V out 1 and V out 2. Or, different things. That out makes no sense, okay? Don't do that. Okay, so again, look at the font disparity. Look at the font size here and the font size here. Why is this font so much smaller than this? It makes no sense, right? These fonts all have to be the same. Okay. All right. So let's move on to, again, remember, see, they have, we have a need space here, 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 and here. These have to be subscript, V driver, right? So driver has to become a subscript. Okay. Oh, one more thing. When you're citing a paper, it should be like this. First, the first author's name. So Smith, maybe et al. If there are more than one author. And then you say ISSC 2017. Or if it's a journal, you say JSSC December 16. Okay? So it starts with the author's name, then the journal of the conference, and then the year. If it's a journal, then it has to be, the month also has to be specified because, of course, journals have different months. All right. Going now to this slide. This slide is okay. The way I would actually do this is I actually took out these arrows because it's not clear what this means. Where are we going? Generally, what we would do is probably something like this: large swing, and then the two-sided arrow to high bandwidth, and a two-sided arrow to good linearity, and then a two-sided arrow back. Okay, that shows exactly the trade-offs. The two-sided arrow, and then of course in the middle of it we write power. Okay. Any questions so far? All right, so let's look at this diagram. So this is an example of a case where we have not followed compactness in our drawing, right? You can see that there's this big box and this little font inside. And again, this big box. So the way this should work is that, okay, so why is this box so long? Because we try to fit low speed mux in one line from here to here. And that's all we could do. So we shouldn't do it that way, right? So maybe we should write it like this: low speed mux. And then we go like this so that the box and the font are closer to each other. If you want to start with this font, that's fine, but this box would be much smaller so that when we blow it up in PowerPoint, it will be much more visible. Now, when I did this, of course, I violated some rule. Here, low speed needs a hyphen because low speed is an adjective for mux. And as I said, the adjective has to be one word. That's why it's hyphenated. But here I dropped the hyphen because if I keep the hyphen, it looks awkward. And that's okay. That's a minor infraction that sometimes we do, but for the most part, it's okay. All right, so both of these, as you will see later, I asked Yikon to redraw these. I should redraw them much better by rearranging these things and making these more compact. Okay, this we have different dashed lines in iDraw. This dashed line is not very good, doesn't work all the time. So I suggest that use the shorter dashed line, not this one. Okay, so maybe we have that somewhere else. I guess the previous ones were not iDraw. This is done in iDraw, so use the shorter dash. So it's right here, shorter dash. It has the same thickness, but it's a little shorter. Okay, so again, you can see that this font is so little and this inverter is so huge. Now, in iDraw, I have given you guys a file that has many symbols in it. I think Yikon and Atharov have that, right? Okay. That file is created to make your life easier, not harder. So you should use it. That, as I described in the iDraw video, everything that you need, almost everything that you need is already in that file. So inverters, we already have in that file. I don't know, I don't think this is the inverter I drew in that file. It's something else. Everything that you want is there. And the purpose of that is so that you can easily draw things. You can keep the grid on so that you can easily place them next to each other. The lines are completely on the grid. They don't go off the grid. They don't protrude into something, etc. So those, once you get the hang of it, it is a very efficient drawing tool. Okay, I play with different drawing tools, and that is really the most efficient drawing tool. So try to take advantage of everything that it has. For example, I think we'll see that a little later. Okay, before we go, when you have something like this, it's a loop, right? And it's a block diagram. It is very important to show the flow of the signal. So here, we know that signal goes this way, right? So you need an arrow right here. And then an arrow right here. Okay, and an arrow right here. Well, I actually can draw this on slide, but on this screen, but it's not a very good screen, so that's why I'm drawing on my surface, and then an arrow here. Because then the eye can easily see that, okay, yeah, that's the loop. This is important because actually in many phase lock loops, we draw the divider on the bottom, in which case the signal goes this way, not that way, right? So whenever you draw a loop consisting of a bunch of blocks, you need to make sure that you show the direction of the flow of the signal. Okay, what's wrong with this picture here? So when we draw plots in iDraw, so let's want to plot something like this, low pass response, a general low pass response, or I don't know, a step response or something, right? The way we do it is that the plot itself is a thicker line, you can see here, but the arrows, the axes, are thinner. They should not be thicker because then the eye cannot tell the difference between the axes and the plot. So these should be thinner. In fact, these should be as thick as these lines that connect different boxes to each other. All right, so that's important. Okay, one more thing that I wanted to show you. Well, I guess it will come back later. All right, so same situation here. Okay, all right, so let's talk about this. CML driver. Okay, here we are going to the circuit level and want to make sure that our circuits are drawn nicely. All right, so we're going to start with these resistors. So if you go to the symbols file that I have provided, I have shown a resistor. Again, that's in the iDraw video. And I have shown R1 on this side and R1 on this side. This has been done after many years of experience. This and this are chosen with proper spacing with respect to the resistor. The spacing is chosen very carefully. Okay? It's not too close so that the tips of the resistor run into the resistor, into the letters. And it's not so far that doesn't look good. Okay? It's done very carefully.